Okay, I'm going to show you how to do some of these free fall problems. When we do these, we're really looking at two equations. It's going to be, we want to know the velocity of an object in free fall. It's going to be acceleration, which is 9.8 times however long it's in the air. So each second, it's going to increase by 9.8 meters per second. Okay, then we have distance. And with this equation, we can figure out distance and time. And then so distance equals 1/2 acceleration times time squared. It's really important to remember that. I'll show you a few of these problems have a different way to solve them. Okay, so if we look at the first one, it says, let me get this all get it all in there maybe. Yeah. It says an object falls from a high building ignoring air resistance. What would its velocity be after 6 seconds of falling? Okay, so we look here. So we have a time, right? So we go here, we have a time, and then that's all we have, right? So if we look at an equation like that, we're really gonna, unless it's asking for distance, we're gonna use this first one right here. Okay, so if we just plug that equation in, so it's gonna be velocity equals acceleration times time. And then this could be velocity final. Velocity final, acceleration is 9.8, and then it's time, 6 seconds. Then we do our math, get our calculator out, and go ahead and do it. We go 6, so 9.8 times 6, 58.8. We'll just round that up. So 59 meters per second. So that would be, let me straighten that up. That'd be that one. Probably good there. So that's that one. Okay. All right, I'll do a couple here, and then you go ahead and try them. You can always come back. I'm going to do each problem so you can see how to do it. I may have you skip some, but we'll see. So it says an object falls from a high building and hits the ground in 9 seconds. Ignoring air resistance, what is the distance that it fell? So here we're asking for a distance. So it's going to be this equation right here. I always like to write it in. Distance equals 1/2, or 0.5 if you want to write it like that, a, and then time squared. It's important to remember the time squared. Then we look back at our numbers. This is the time, and then that's it, right? So we rewrite it. D is 1/2. And acceleration is just due to gravity, so it's 9.8. Sometimes people say 9.81, but we're not going to worry about that. We're just going to do 9.8. And then our time is 9 seconds. Okay, so then following order of operations, we want to do this one first. It's going to be 81 times 9.8 times 0.5. So then if I do all the math, put my calculator back, put this in here. So if I do the math, it's going to be 81 times 9.8. That's not right. 81 times 9.8 gives you that. And if you want to times it by 0.5 or divide by 2, gives you 396.9. That's going to give us 397, let's say. So that's 397 meters. Okay, that's that. Look at the next one. It says, ignoring what is the velocity of the piece of glass. Oh wait, it's a different one. Okay, so then we have number 3. So 3 says, during a tornado in 2018, the Peachtree Plaza Westin Hotel in downtown Atlanta suffered damage. Suppose a piece of glass dropped near the top of the hotel, falling 215 meters. Ignoring air resistance, how long would it take the piece of glass to hit the ground? So here we have a distance, right? 215, and then that's all we have, right? And it wants to know time. So this is going to be our equation. D, let's write this out, D is 1/2 a times time squared. And then we're going to put our numbers in over here that we know. So 215 is our distance, and that's going to be 1/2 times 9.8 times time squared. That's what we're going to solve for. We want to rearrange this algebraically to get times squared by itself. So we have to first get rid of the half. So if we're dividing by 2, if we multiply both sides by 2, like 2 over here, then and 2 over here, this would cancel this one, and we just would be left with 9.8 and then times squared, and we have this over here. So then we need to get rid of 9.8, so we're going to divide by 9.8, both sides. This will cancel, and then we're just left with times squared. And then on this side, we have 2 times 2, 15, divided by 9.8. And then we still have times squared over here. So what we have to do is do a square root of that thing. And then we just have time. So then if we do our math, okay, so we got here 215 times 2, 215 times 2, we get that, divided by 9.8, we get that. And then we have to do a square root of that. I'm going to turn my calculator like this. Let me plug it in. Turn it like that. I should be able to get a. If I need to, there we go. So I get that. And then I'm going to do the square root, which looks like it's right there. 6.6 is what the answer is. So then, how long would it take the piece of glass to be 6.6 seconds? That's the answer to that. Okay, we keep going. It says, ignoring air resistance, what would the velocity of the piece of glass be when it strikes the ground? Again, we're just looking at velocity due to free fall. It's going to be this real simple one. Velocity final equals A times T. So we just want to figure this out. A is 9.8. Time is, we get this up here, right? 6.6. We don't have that, but we figured it out right here. Then we do our math again. 9.8 times 6.6. 64.6. So we're just going to say 65 meters per second. So that's that. Okay, now I think you could probably try the rest of these on your own without me showing you. So go ahead and try them and you can come back and see what answer I got on this video. Okay, and I'm going to keep going. Okay, so here we have an object falls from Transco Tower in Houston and takes 15 seconds to reach the ground. What is the velocity of impact if air resistance is 0? Okay, again, you want to know velocity. This is the only one with a velocity, so it has to be that one. So V is A times T. V is 9.8, and the time is 15 seconds. So we do our math again. 9.8 times 15, 147. So that's a pretty fast moving thing. 147 meters per second, really fast. Okay. And then how tall is the building? So here it wants to know a distance because it's going to hit the ground, it's going to fall from the top and hit the ground. What's that distance? We're going to use that equation. Let's put that in right here. D 1/2 A T squared. Okay, so this is going to be D 1/2 times 9.8 times 15 squared. And we're going to do our math. We're going to follow the PEMDAS thing where it's the exponents first. We do this. Okay. So what we have is 15 times 15, right? 15 times 15, 225, and then we're going to times that by 9.8, and we're going to divide it by 2, about 1102. Pretty high. It's meters, quite a few feet, about 3,000. Pretty high. Okay. And so we do that. Don't worry about these. Let me take these off. You can try, I'm not going to worry about them. So skip those. It says, if the Transco Tower were actually 3,000 meters tall, how long would an object take to free fall off the top of the building? Okay, so if it was actually 3,000 meters, which is pretty high, or 3,000 feet, yeah, 3,000 meters, 3 times as tall, right? And it wants to know how long. Okay, so distance, 3,000, that's d, and then 1/2 times acceleration, 9.8, and then t squared. Right? So we're going to plug this in, and we could move some stuff around. Let's do the math first. It's a different way of looking at it. So if we did 9.8 times 0.5, 4.9, so we have 3,000 equals 4.9 t squared. Then we're going to divide both by 4.9. That's going to give us 3,000 divided by 4.9. That gives us 612. That's t squared, but we don't want t squared, so we're going to do the square root of both, and that'll give us t. So if we turn it again, see if I can change real quick. Oh, gotta pick it up. Okay. And if we do the square root of this thing, 24.7. It's quite a long time. 25 seconds. Okay. So that's the answer to that one. Let's keep going. You can pause it now if you want to go to the next one. So if you look at this, it says Wile E. Coyote, if you've ever watched Roadrunner and all that. Toss a bowling ball off a cliff to try to catch the Roadrunner. The cliff is 132 meters high. That's a distance. That's all it gives us. How long? It wants to know time. Gives us a distance. Can't use this one because we don't know time and we don't know this. So we have two unknowns. We'd have to use this one. So if we put that in, d is 1/2 a t squared. So the distance is 132. Let me put it over here. 132 is 1/2 times 9.8 times t squared. That's what we want to know. This one. So then we'll just do the math. 132. This is going to be 4.9 t squared. Divide both by 4.9. And then we're going to do some math. And really, we do that and we do the square root. That's going to give us t. And let's see what it is. So 132 divided by 4.9 gives us that. And we have to do the square. Or square root, I'm sorry. 5.2. 5.2 seconds. Okay. And then if we keep going, what is its impact velocity? Velocity when it hits the ground. So then we would have to do distance. 130. Oh wait, sorry. We don't. We got the seconds. So velocity final is acceleration times time. Velocity final is 9.8 times 5.2, which is the time we figured out here. We do our math. Let's put this back on here. 9.8 times 5.2. 51. So 51 meters per second. That's that one. Okay, then how far does it fall in the first 3 seconds? So distance, again it's a distance, so distance 1/2 a time squared. So distance, what we want to know is going to be 1/2 times 9.8 times 3 seconds, 3 squared. That gives us 1/2 times 9.8, and then it gives us times 9. So then we bring our calculator back. Do the math. It's going to be 9.8 times 9 divided by 2, 44, say. 44 meters. Okay, that's that. And, yep. And then we look at, so how fast is it going at the end of 3 seconds? So we would do V equals A times T. So V is 9.8, the time is 3 seconds, so 9.8 times 3. 29.4. That goes over there. Okay, and then, how long would it take the same ball to fall if the cliff was on the moon? 1.6, just giving us a different acceleration. So we're doing time, or we're going to do distance. Well, we can do this actually. V of F is A times time. Oh, but actually, we can't use that. We need a distance. So forget that. So distance, 1/2 acceleration is time squared. Okay, we know the distance is 132. I'm going to put it up here. Equals 1/2. This is now the gravity, not 9.8, but 1.63. And then the time, we don't know, but it's squared. And then we're going to multiply 2 over here. And we can just do this first. 1/2 times 1.63. We do that math. So we do 0.5 times 1.63. We get 0.815 t squared equals 132. Then we're going to divide both sides by 0.815. But we also have a t squared, so we're going to square root that. And then do that to the other side over here, and we're good. Let's do the math. It's going to be 132, down, 132, 132 divided by 0.815, and then we're going to do the square root of that. Got to turn it again. Do the square root, 12.7 seconds. So on Earth, it would take 5 seconds. On the moon, it takes 13. And it says this one. So if you drop your cell phone in the bathroom in front of the mirror while the water is running on the sink below, if you're 0.45 meters above the sink, how long do you have before your cell phone is a goner? It's this one, D, 1/2 A times squared. Distance is 0.45. 1/2 times 9.8, and times squared, we don't know. We're trying to figure out. So then we're going to, let's multiply this through. It's going to be 0.45 equals 4.9. I just did it, I've done it before. Times squared. Divide both by 4.9. And then we just do the square root of this thing. And that's going to give us t. Let's see what it is. Okay, go here. Here. There we go. So 0.45 divided by 4.9. We get that. All right, but then we do the square root of this thing. We get 0.3. 0.30 seconds. So you better have really good hand-eye coordination to grab it. That's all of them. See how you do. We'll review any class that you need help with.